Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the third part of the perimeter topic, where we'll be looking at arc length and the perimeter of a circle sector. So here we've just got the formulas. I've written it twice, as if you have seen the previous video on circle circumference, you'll know that there are two ways to write down the formula for a circumference of a circle, and it's basically just your own personal choice. So you can see here we've got the 2 pi r option and the pi diameter option. It's completely up to you, that's why I've put or. Make sure to either take a screenshot of this screen or to make a note of whichever of the two formulas you want to use. But the formula for the arc length of, as you can see, a circle sector here, the arc length being this bit here, okay, so the curved part of a circle sector, is basically we're going to work out the circumference. So as you can see, we've got 2 pi r or pi diameter. Then you're going to times that by a fraction, which is, we've got theta here, that just means the angle, okay, the angle inside the sector, out of 360. Now the reason for this bit here is that it's basically like what portion of the whole circle, if you imagine this sector is obviously originally part of a whole circle, what portion of that circle are we actually using? Now a whole circle has 360 degrees at the centre, doesn't it? So we're just saying, okay, well, maybe it's like 25 degrees out of 360. So basically just work out the whole circle circumference first and then times it by what portion, what fraction of the circle we've actually got that we want to work with. So I've got pi d as my option because that's the one I prefer to use as a formula up in this corner. But either way, just remember it's whatever formula you use for circumference times it by the angle over 360. So in this example, work out the arc length of the sector. Here we've got 58 degrees as our angle and 6 centimeters as our radius. So the arc length is pi times the diameter. Now in this case, obviously with sectors, you're most likely to be given the radius, but I know that the diameter is 2 times the radius, so I know that's actually going to be 12, isn't it? Pi times 12 times by what fraction of the whole circle am I working with? Well, I've got 58 over 360 degrees. And then we just put it in the calculator. So pi times 12 gives me the whole circumference, and then I actually only want 58 degrees out of the 360. And as a decimal, that gives me 6.07 ... So I'm going to round that to 6.1. They should tell you in the question in an actual exam paper what to round it to, so don't worry about that. In this case, I'm doing 1 decimal place. And that's literally it. Now, they don't tend to give you this formula, so you just have to remember it by that logic. Okay, work out the whole circumference, then times it by this fraction. That's literally it. Okay, so have a go at this next one if you already feel like you're happy to do so with this formula that we've been given. Work out the arc length of this sector, so we've got arc length equals pi times the diameter. Now the diameter is obviously 2 times the radius, so I know that's 25. Times by the angle, 134, over 360. And again, I just then put it in my calculator. So pi times 25 times 134 over 360. Which gives me 29.2 to 1 decimal place. It's as simple as that. As long as you've got the formula, it's just a bit of substitution really, isn't it? Okay, so this one is similar, but I don't know if you can notice the only difference is that the degrees or the angle we've been shown, 90 degrees, is actually on the outside of the sector, isn't it? We actually want to know this angle. So they might do that. They might actually give you the angle on the outside. Just double check. Do I have the angle on the inside or the outside of the sector? Obviously, we need to work with the angle on the inside. So first of all, what I need to do is 360 minus 90 degrees, which gives me 270. So actually my angle is 270. So it's a bit of a trick question there. They could do that. They could make it a little bit harder and that you just have to make sure you've got the right angle. So I know that it's pi times the diameter. Now 3.4 is obviously the radius, so I've got 6.8 as my diameter, times 270 over 360. Some of you might have noticed obviously that is technically 3/4, isn't it? So you might decide to use 3/4 or just stick with the formula that we were working with. So pi times 6.8 times 270 over 360, or 3/4 if you're happy to do that, gives me 16.0 if I would do it to 1 decimal place. Okay, so exactly the same thing, just double check, have I got the correct angle? Have they actually given me the right angle? Okay, this time it's very similar. The only difference is they've said work out the perimeter of this sector. The perimeter is, as we know if you've seen the past few videos, is all of the sides added together. So yeah, we do have the arc length here, but we also have these two other sides, which that's a radius and so is this, isn't it? So that's another 19. So in this case, we're going to work out the arc length first still, but we're also then going to have to add on 19 and another 19 to get the whole perimeter. So first of all, let's do the arc length. Same formula as before. Pi times the diameter, which I know is 38, because 2 times 19 is 38, times by the angle, 211 over 360. So pi times 38 times 211 over 360. Which gives me roughly 69.97. Just going to write down a couple of the decimal places there. Okay, so that's the arc length. That's just this curved bit. Now though, if I want the whole perimeter, I'm going to need to take that 69.97 and add 2 lots of 19 because there are 2 other sides. So I'm going to take my answer, I'm going to put plus, and it'll copy that whole answer there. 19 plus another 19, which gives me 107.97, which if I round it to 1 decimal place is actually 108, isn't it? 108.0 to 1 decimal place. Okay, there we go. So that's the only difference. If you double check, have they said arc length, which is just the curved bit, or have they said perimeter, which is all of the sides added together additionally? So it's an additional step at the end. Okay, this one's a little bit different because now we've actually been told the arc length. So they've said the arc length of the sector is 6.1 centimeters. Work out the radius r. So we're actually going to have to work backwards. I know that my arc length is pi times the diameter times the angle over 360. And that technically then equals 6.1, doesn't it? So if I fill in the other piece of information I know that the angle is 50 degrees, isn't it? So I've got pi times diameter times 50 over 360, which equals 6.1. So all that's missing, can you see, the only thing that I don't know in that formula is the diameter. Now you might also want to use 2 pi r instead of pi times diameter, that's absolutely fine, whichever you prefer. So I'm going to rearrange this to solve for the diameter. I want to get the diameter on its own. So firstly, what I'm actually going to do is divide by the whole of this fraction to move it across. Obviously this is going to be a calculator question, so I'm going to get my 6.1 divided by 50 over 360, and we're going to get a lot of decimals, I think. Oh, not too bad. So 43.92. So pi diameter is equal to 43.92. So actually what that's telling me is the whole circumference of that circle is 43.92. Now all I want to do is just get diameter on its own. So the last thing is to divide by the pi. So take my answer, divide by pi. And that gives me 13.98. Now if I round it to the nearest whole number, let's go with that. That gives me 14, doesn't it? The only thing then is because I've used pi times diameter, they've actually asked for the radius. So I'm going to have to just go to the end and half it. So the radius was actually 7, wasn't it? Because the diameter is double. So just double check whether you've used 2 pi r, you'll naturally get 7 at the end. If you've used pi diameter, just remember you need to half it in this case. And that's it. So just write out the formula that you know you would use to find the arc length in the first place, and then sub in any information you have. And then it's just after that, it's just basically algebra, isn't it? So that is everything you need to know for arc length of circle sectors. The last part of the perimeter topic is using perimeter with algebra. After this, the next topic to look at would be area. So thanks for watching this video. If you found it helpful, please make sure to like and subscribe and leave down below any questions or comments you might have.